In this lesson, we're going to explore more about logarithms. In the previous lesson, we learned about solving equations using them. Today, we're going to talk more about how they relate to the exponential functions and explore the graphs of them. So let's review a couple things about yesterday, or the previous lesson we learned. You can solve exponential equations for the exponent if it's in the following form. So if you have some sort of base written to the exponent equal to some amount. If you can get it to that form by kind of getting things over to the other side, adding, subtracting, or dividing, then you can use logs. So remember that we were able to get it to this form, log of some base, log base of whatever, of some amount equals the exponent. So you can see that relationship here, that base down there went to the base of the log. The amount that it was equal to actually goes inside the log. And then the exponent, when it's in log form, that's all the way on its own side. So as an example, if you have 4 to the x power is equal to 20, you can rewrite that as log base 4 of 20 equals x. So you can see everything's kind of in its own place. The base of the exponent is the base of the log. The amount that it's equal to is the number in the log, and then the exponent itself is what you're solving for, so that goes on the other side of the equation. And reminder, we say log base 4 of 20. And so I want you to see if you can just evaluate this in Desmos. So remember how to type log base 4 of 20. To get that base in there, you'll hit the log, and then you do shift minus. Do this with me, press the 4, and then do the right arrow, and then you can put the 20 in. And that gets you a value of about, it gives you an amount of about 2.1609. And we can check that by plugging that in. So you can say 4 to the power of 2.16, go out several decimal places, and you can see that gives you approximately 20. So that does give you the number inside the amount in the log. So the exponent is what we just solved for using the log. And again, that looks like this. Pretty simple to type into Desmos. So now let's explore that relationship a little bit further. We have base to an exponent is equal to amount, which translates to log base of that amount is equal to the exponent. Those are interchangeable. You can write either way, one or the other, doesn't really matter. They mean the same thing. So let's do this example. We're going to write this in log form. Example 1. To write it in log form, we'll start by writing the log. And we identify the base of the exponent first. Now, what number represents the base here? It's the 9. So the 9 is your base. So that 9 is going to go right there. So we write it down in the subscript. In the parentheses, we put what it equals to. So in the amount part, that's going to go here. That's going to also go inside the parentheses in the log. So we do 1 over 81. And then we set it equal to what's left. And what's left is our exponent. Our exponent gets brought over to the right side of the equation, and we say -2. So we say log base 9 of 1/81 equals -2. Since these are numbers, we can actually check that. So if I did 9 to the -2nd power, which the calculator gives you a decimal where you can convert, that is 1 over 81. So we know that number is right. And if I typed log base 9 of 1 over 81, let me move this over here. I could say log subscript, so shift minus 9, right arrow, parentheses, 1 divided by 81, and close that up. And you can see it gives you -2. So if you have numbers to work with, that's an easy way to check it. But if you only have variables or letters, you have to know that formula. One more time, let's do exponential form. Write the following in exponential form. So see if you can do this one on your own. All right, think you got it? Start with your base. What is your base here? We only have letters. That's right, it's going to be a. And we're going to raise it to what power? We're going to raise it to, since it's in this form, your exponent's over here, it's going to get raised to the r power. And we're going to set it equal to what's in the parentheses. So the amount goes over here. So a to the r power equals g. A to the r power equals g. So I like to think of this as out back, right? If it's in log form, you can start with the base, you can go out to the other side, then you can come back into the part that's inside the log. So a to the r is equal to g. I should circle that. All right, the next example is for you to try on your own. Pause the video. Try these two problems. See if you can convert them into the other form. So the first one's in log form, convert it to exponential. The second one's in exponential form, convert it to log. So let's convert to exponential. And then for this one, convert to log. All right, pause the video so you can try it, and I'll reveal the answer. Okay, hopefully you've had enough time to check this out. We'll go over the answer. So this is going to be 3, that's your base, to the 4th power. And that's going to be equal to 81. So 3 to the 4th power is equal to 81. You could check that one in your calculator if you needed to. All right, part B, since there's a variable, you can't really check that in your calculator, but we want to write it as a log. So we'll say log. Base is 5, so that's going to be the subscript. In the parentheses, it's going to be 3. And we set it equal to your exponent. So remember, your exponent in log form goes on the other side of the equation. So log base 5 of 3 equals y. Well, good job on those. Hopefully you got those right. Next video, we'll talk a little bit about more about the graphs of logs. Thanks for watching.